anyone figure out which of those graphs goes with the equation k of x equals 2x minus 4? Eli?
C.
Very good. Why is it C?
Because -4.
Ah.
Intercept.
The -4 is the y-intercept.
So I looked at whichever one is -4, and the only one that's -4.
There he is. The only one that crosses the y-axis at -4 is C. So the correct match to little a was big C graph. What about little b? Sabrina, what'd you get?
For B, I got A.
Why?
Because it was the only one that went to 5
Correct. Did we need to use the slope for any of these problems? No, siree. All we needed to look for was the intercept. Our y-intercept should have been 2. The only graph that crosses positive 2 is capital A. What about C? Did anyone get C? Carl, what'd you get?
D.
Excellent. Why?
Because it's the only one that passes away. It was honestly process of elimination.
So you matched up all the other ones and then you matched those two together? Well, let's think about it. Do you see the +4 that I circled?
Yeah.
That means that our y-intercept is 4, right? Why would that match to D? Why would that match to D? Does anyone else know? Joseph?
Because D is showing a positive y-intercept.
Very good. D is showing a positive and specifically +4 as the y-intercept. Excellent. Okay? So that's why D belongs with C. And then for little d, did anyone get that one? Process of elimination. What's the answer? Diana?
B.
B. Very good. Now, can anyone explain why it's B? All good. Layla? If you answer my question.
What?
It's a sort of riddle.
Why is the last one capital B? Or the restroom. Grayson, go ahead.
So, what was the question? Okay, wait. Okay, hold on. So, the y-intercept is -2.
Mhm.
B, process of elimination is the only one left. And it has y-intercept of -2.
Very good. Layla, you can go at the end of the period. Okay, so,
Wait.
To-
Can I answer that? Can I go to the restroom?
sure. Okay, since today what we are learning about is something called transformations, okay? We're going to start super basic in terms of transformations. We're just going to be moving things around from left to right, up and down. And then later on, we're going to shrink and expand our graphs. But that's a little bit later, okay? For right now, we're just going to move everything left or right or up or down. All right, the first thing that I want you guys to do on this page, I need you to highlight that our parent function is f of x equals x, okay? That is the parent of all parent functions. It's the most generic. It's when our slope is 1 and our y-intercept is 0, okay? Now, it says a transformation changes the size, shape, position, or orientation of a graph, okay? So we're going to be learning about transformations that do all of those. But the first one, the most basic one, is something called a translation, okay? And a translation is when you move something in one direction. You don't change the size of it. You don't change the shape of it. You just move it from one point to another, okay? There's 3 different kinds of moves. We can either move something left, we can move it right, we can move it up, or we can move it down, okay? So anything that's horizontal would be left to right, okay? So a horizontal translation, it's written in the form y equals and then f of x minus h, okay? The big thing that you guys need to notice here is that we are subtracting h from every x value, okay? That is a horizontal translation of the graph y equals f of x, which is our parent function, where h is not equal to 0, okay? So think of, let me stand right here, and think of me as your parent function, okay? Me standing nice and tall. If I take one step to my right, Did my body change at all? Did my position change? Yes, I moved over, right? That's exactly what a translation is. It's just saying, okay, do you see how the black graph on your page in the horizontal translations looks exactly like the blue and the red one? It's just moved over a little bit to the left and a little bit to the right. That's what a translation is, okay? So when you move it to the left, in red, I want you to write that this is a left shift, okay? We shifted our graph, only shifted, we didn't change its direction, we didn't do anything, we just shifted it to the left. In the blue, I want you to write that that is a right shift, okay? And we're shifting it by the value of h. So whatever that value is that you're subtracting from x, that's how much you're shifting your graph. Okay? Take a look at the vertical translations, okay? The graph of y equals f of x plus k is a vertical translation of the graph y equals f of x, okay? Highlight y equals f of x plus k. And then circle the plus k. Oops. Can someone tell me, look at the two equations that we highlight for a horizontal and a vertical translation. Does anyone notice the difference between those two? Look at the two equations for a horizontal translation and a vertical translation. What's the difference, Layla?
How it's subtraction and addition.
Okay, one difference is that one's subtraction, one's addition. What's another difference?
So
Sabrina?
there's no, you have to put together f of x and the other one is already together.
Very good. F of x, we're subtracting h inside the parentheses. Do you guys see that? For the one over here? For the one over here, is the k inside the parentheses? No, it's outside, okay? That's a big difference, and we're going to see that down below, okay? So whenever you have a graph where you're adding k and your k is outside the parentheses, that's going to be a vertical translation. So in the blue, I want you to write that it's an upshift. And in the red, I want you to write that that is an example of a downshift, okay? Okay? So you're either shifting up or you're shifting down. But look at those two equations, those two lines, compared to the parent function. Did it change at all the actual look of the graph? Like how the line looks? No, right? It's the exact same line, it's just shifted a little bit up to get the blue one and a little bit down to get the red one, okay? Now, we're going to do two examples where we're going to find out the horizontal and the vertical shift together, and then I'm going to leave the next two examples to you guys to see if you were paying attention, okay? All right, so go ahead and scroll down a little bit, okay? It says graph and describe each transformation. Let f of x be 2x minus 1, and then our transformation is going to be g of x equals f of x plus 3. Circle this one in red, circle this one in black. Okay? So f of x is going to serve as our parent function. Write that in there. This is our parent function. How do we know that it's our parent function? Well, look at g of x. You see how g of x depends on f of x plus 3? Okay? You need to start with your parent function, and then your transformation is based off of that function. Okay? So, if f of x plus 3 is our transformation, let's start with the parent function, which is f of x, and let's graph it. Does anyone know how to graph this parent function? F of x equals 2x minus 1. Dana, how would you do it?
Well, first, don't you add the fx to the equation, so it'd be gx equals parentheses 2x minus 1 plus 3?
I love that. You said that. But let's graph the parent function first. That's an awesome connection. Sabrina? Why?
Because it's
What's that form? Grayson, help her out.
Slope intercept form.
Good. This is in slope intercept form. So the information that we know right off the bat is we should know our slope and we should know our y-intercept. Who can tell me what the slope is of our parent function? Eli? 2, or 2 over 1. Excellent. Does anyone know the y-intercept? Layla? -1. No. So, if our y-intercept is -1 and our slope is 2 over 1, let's just graph that. So just like Sabrina was saying, at -1, we're going to put a dot. Make sure you're doing all of this in black, okay? Because this is our parent function. If our slope is 2 over 1, what should we do from this point? If our slope is 2 over 1, what should we do from this point? Eli? Up 2 and then to the right 1. Perfect. So our next point is going to be here. And let's do it one more time. Up 2 units to the right 1 unit. Our next point should be here. So we've got 0, -1. The next point is 1, 1. And then the last point is 2, 3. Now, you guys can draw a straighter line because you're in Notability, but draw a straight line through all of those points. And then at the top, label it your parent function. Okay, let's take a look back up at our transformation. So our transformation is saying, okay, take f of x and add 3 to every single value, okay? Now, this +3 indicates a vertical shift. So underneath the red circle, right, that this is a vertical shift. Of 3 units. Okay? It's a vertical shift of 3 units. Okay? The reason it's vertical is because the 3 is not inside the parentheses, right? Do you see how the 3 is being added to f of x, not x? So remember, look back up at our core concept, right? Do you see when when it was plus k outside the parentheses? It's a vertical. When you are adding or subtracting something inside the parentheses, it's going to be a horizontal shift, okay? So this is going to be a vertical shift of 3 units up because it's +3 as well. So look how we do it. Every single point, we're just going to move it 3 units above the previous point. So take 2, 3, move it 3 units up. Take 1, 1, move it 3 units up. Take 0, -1, move it 3 units up. And then put different points at each of these. And then you're just going to draw a line that goes through all of those. This is what we call our transformation. G of x equals f of x plus 3. Okay, now let's label these points. What's that point all the way up there in red? What's the coordinates of that point? Carl?
2, 6.
2 comma 6. What are the coordinates of that middle point? Carl?
2, 4.
2 comma 4. Oh, not 2 comma 4. 1 comma 4. Do you see that? And then what's the last one, Carl?
-2. No, 0 comma -2.
0 comma Layla?
Oh,
Positive 2. Okay? Now, your job within your group,
Oh my god.
3 is added to all the blanks.
increase by 3.
So much.
That's supposed to be increase. My handwriting is awful. Okay? Now, why do you think the x values stay the same, but the y values increase by 3? Joseph?
because they're only going up.
Correct. Do you see how all of our arrows are straight up? So we're not changing the x value at all. We're just moving our graph up 3 units for each of those points, okay? We're going to do one more example, and this is going to be a horizontal shift. And then I want you guys to try 2 on your own, okay? Let's take a look at number 2. It says graph, so we have the same parent function. If you guys want to copy and paste it, that's fine. I don't have the ability to do that because I'm working in Explain Everything. So I'm just going to have to copy down my parent function again, okay? So the points were 0, -1, 1, 1, and 2, 3. 0, -1, 1, 1, and 2, 3. 3, 1, comma 1, and 0, comma -1. Oops, -1. Okay? We're going to draw that line through all the points, and we're going to label this our parent function. Okay. Now, the next thing that's happening in this example is h of x, make sure you circle this one in blue, is equal to f of x plus 3. Compare number 1 and number 2. How are they different? What's the difference in number 1 and number 2? Diana?
The x is in parentheses with the 3.
Correct. The 3 is now being added inside the parentheses. Do we see that? Now, I want you to draw a little box around the x, the plus, and the 3. I'm going to show you guys a little trick, okay? This area in between the parentheses, think of it as its own little world. And we call that world opposite world. Just bear with me. Okay? We call that opposite world. Okay? Now, how opposite world works is anything that happens in opposite world, it's not going to be what you think. So if we were to add 3, right? We know that this is a horizontal shift. Because if you remember from our core concept, right? If you're adding something and it's inside those parentheses, it's going to be a horizontal shift, right? Now, when you plus 3 horizontally, right? Would that indicate that we should move our graph, if we're adding 3, to the right or to the left? If we added 3. Carl?
Right.
To the right. That's what most people would think, right? If you're adding 3, you're going to move your graph to the right. Since it's an opposite world, guess where we move it? To the left. Okay? So, you're going to write that this is a horizontal shift, 3 units to the left. Okay? Now, I'm going to explain why it's called opposite world. Okay? But I want you guys just to know that if it's inside parentheses, that world inside the parentheses is called opposite world. Okay? So instead of moving 3 units to the right, which we normally would do since it's plus 3, we're actually moving 3 units to the left. So we're doing the opposite of what we should do. Okay? So look what happens. Every single point, we're just going to take an arrow and move it 3 units in the other direction. 3 units to the left, 3 units to the left. We have 3 new points. And we're going to draw a line through those 3 points. Let's put our coordinates. The first one is -1, 3. The second one is -2, 1. And the last one is -3, -1. This is g of x equals f of x plus 3. Okay? So we moved it 3 units to the left. Does anyone see the pattern in the coordinates? Do you remember how we noticed a pattern in the last coordinates? Does anyone notice the pattern in the blue coordinates? Carl, what do you think it is?
Take away 1 at a time for the x and y, and then for the y, you take away 2.
That would be the slope. You're close. But you're saying the slope for like the black line, it goes down by 1 and then,
Oh, I was talking about the blue line.
yeah. Zoe, do you see it? Okay, so y values are staying the same. What's happening with the x values? Mm-hmm. Excellent. The x values decrease by 3. Eli, were you going to say the same thing? So you guys are doing the next 2 questions, the following 2 transformations. All right, now, what kind of transformation is g of x equals f of x minus 2? Vertical, good. How do you know? How it's written, because the 2 is outside the parentheses. Let's be specific. Now, be more specific about vertical. How am I going to move my graph?
Down to.
There it is. Down 2 units. Okay. Now, someone else help me graph the parent function. Zoe? Good. How'd you know that? No, you don't just do. How did you know that the slope was 3/1? Why'd you pick 3 and not 1? Yep, it matches up with the m. That's our slope. Okay, what else do you know? Excellent. Y-intercept is 1. Okay, can we graph that? Help me. Dot on the 1. Yep. Why do I do that? It's a positive. What else? Rise over run. Good. So let's do it one more time. And we should get these 3 points. Okay, let's label this our parent function. And then I'm moving everything down 2 units. So how many groups, honestly, moved everything down 2 units and your transformation looked like this? Excelente. Good work, peeps.
Can we get candy?
No.
I think we should. I think.
You guys always think you guys should get rewarded, okay? And so we're going to label this. How many people labeled their transformation g of x equals f of x minus 2?
What if it isn't a reward though? What if it's just a snack?
Okay? All right, for the second one, parent function's the same. Okay? If you did, you would have gotten what, like 2, 5, 1, 2, and 0, -1. And then these were 0, 1, 1, 4, and 2, 7. Yes.
Are there
Yep.
quiz or a test that's coming up for this? If we don't label it, will we get points off?
It'll tell you to label them.
Okay.
So if you don't follow the instructions, then yes, you will get points off. Okay? So remember how descriptive we were on the quizzes with our instructions? I definitely upped my game in terms of how descriptive I was. That will... All right. Let's do the second one. So parent function is the same. 0, 1, 1, 4, 2, 7. 0, 1, 1, 4, 2, 7. Draw a line. Oops, not an eraser. This is my parent.
Can I go now?
Yep. Okay. What kind of shift do I do when h of x equals f of x minus 2? What kind of shift do I do for the second one? Diana? Horizontal. How did you know?
Because I saw parentheses and I figured it's horizontal.
Very good. The minus 2 is inside the parentheses. But here's the moment of truth. Is it a right or a left shift? Sabrina? Very good. Why is it a right shift? Why?
Because it's negative, like it's subtracting 2, so it's in the opposite way.
Very good. We're in opposite world here, right? So normal people would take -2 and move to the left 2 units, right? But since we're in opposite world, we're actually moving to the right. A la derecha. Okay? So move every single point 2 units to the right, 2 units to the right, 2 units to the right, and you should get these 3 points, and your graph should look something like this. Your points should have been 4, 7, 3, 4, and 2, 1. What's confusing? This lesson?
Yes.
Okay, the next type of transformation that we are learning about is something called a reflection, okay? Now, when you hear the word reflection, what do you guys think about?
Like
What do you guys think of? Eli?
I was about to say reflection, but I can't say that. The reverse,
Okay, reverse. What else? What else do we think of when we hear the word reflection? When we hear the word reflection. Grayson?
Not a copy, but
Well, where do we see our reflection? In a mirror. Okay? So a reflection is the transformation that flips a graph over a line called the line of reflection. Okay? So, in every single one of our graphs that involves a reflection, okay, we're going to have a line of reflection and we're going to put it as a dotted line. Okay? That dotted line will refer to that line as the line of reflection. Okay? Now, there are 2 types of reflections. There's a reflection over the x-axis, which is when we make y equal to negative f of x. And there's a reflection over the y-axis when we make y equal to f of negative x. Okay? So all you need to do is either make x negative or f negative, and you're reflecting it over an axis. Okay? So, in the example where we are reflecting over the x-axis, I want you to draw a line of reflection, a dotted line, at x. Okay? Every point on your black line is going to be reflected over that line of reflection, okay? So let's say we had a point up here, okay? The point on the red line is exactly the same distance, but on the other side of that line of reflection, okay? Let's take a point down here, okay? We're reflecting that point all the way over the line of reflection to the same point on the other side, okay? So essentially, if you do that for every single point of the black line, you end up with the red line, okay, where you flipped it over the x-axis, okay? Now, let's take a look at the reflection of the y-axis, okay? So, draw a vertical dotted line on the y-axis. Every point on the black graph flipped over this line is going to be the mirror image on the red line. Okay? And if you did that for every single point on the black line, you would end up with the red line. Okay? Now, the easy way to remember this, or to know what to do, is you're just multiplying the outputs by -1, which changes their signs, or you're multiplying the inputs by -1, which changes their signs, okay? Now, once we do an example, it makes a lot more sense, okay? But I do want to point out the actual concept of this lesson, okay? Or this part of the lesson. New? Oh. Reverse and mirror. Okay. A reflection over, is that a reflection over the x-axis or the y-axis? Sabrina? X-axis. So, let's try one example. We're only have time for one, and then we have to end, okay? Okay, so again, f of x equals 1/2 x plus 1. Then we're going to graph g of x equals negative f of x, okay? So, let's take our parent function, and let's graph it, okay? Okay, so our parent function is 1/2 x plus 1. How would I graph that? Joseph?
You would put your y-intercept at 1.
Okay.
And then go up by like 0.5 over 1.
Okay.
And then you would get 1.5 over 1.
So my intercept is 1, and then my slope is 1 over 2. So instead of going up 1/2, I'm just going to go up 1, but over how many? 2. So let's go up 1 to the right 2, up 1 to the right 2. Grayson, what's up? Oh yeah, you're good. Okay. So from here, we draw a line through these points. This is our parent function. Okay. Now, let's label these points. The first one's 0, 1. Second one is 2, 2. And the third one is 4, 3. Are we all good on getting the parent function down? Yes or no? Yeah? Okay. So, once we have the parent function, remember, when we have g of x equals negative f of x, that is, so we're going to find our x-axis and draw a line of symmetry. So draw a red dotted line on your x-axis. So that's my line of reflection. Okay, now this is the part where I need you guys to pay attention, okay? Every single point, we're going to reflect over that line, okay? So this line is going to look the same thing, just reflected onto this side when we're done, okay? So every point, we have to find the distance it is from that line and move the other way across it, okay? So 0, 1, right? How far is 0, 1 from the line of reflection? Allie?
0, -1.
It's 1 unit away, right? So if we were to move 1 down, we would get to the line, right? Move another 1 down, and that's your new point.
Okay, here's the next one would be a -2.
Good.
2, and then the next one after that would be like right there. Lower. Right there.
Yeah. So we're just moving. See how we move down 2 to get to the line? We move down another 2. We move down 3 to get to the line. We move down another 3. Draw a line connecting all of them. Now, which point didn't move? Which point did not move? Ooh, Cooper says -2, 0. Do you guys see how this point did not move? Can anyone tell me why it did not move? Yep.
Just on the x-axis.
It's on the line of reflection. Very good. Very good, David. Okay. Now, let's plug in. Let's figure out what the coordinates are and see if you notice the pattern. Okay. So 0, 1 became what? What's the new point? 0, -1. What was the second point? 2, and the last point? 4, -3. Does anyone see the pattern? What's negative? The y values are all negative, okay? So it's the same thing, just the y values became negative. Just write y values, change sign. Over the x-axis, it is when g of x equals -f of x, okay? Now, yesterday we definitely talked about when we hear the word reflection, we should think of mirrors, we should think of opposites, we should think of a reflection over the axis, okay? So, on the next image, okay, go ahead and copy that parent function down, but now, the difference here on this image is that the negative is inside the parentheses. Do you guys see the difference there? The negative was outside over here. It's inside on this one. So this is going to be a reflection over the y-axis. Go ahead and plot your parent function. And if you're pretty comfortable with this, go ahead and try to reflect it over the y-axis, and then we'll go over it together. Copy it over. 0, 1, 2, 2, and 4, 3. Draw that line through them. Boom, bada bing. Okay. Now, in the previous example, right? In the previous one with the reflection over the x-axis, we changed the values, we changed the sign of the y coordinates, right? So 0, 1 became 0, -1. 2, 2 became 2, -2. And 4, 3 became 4, -3. Do you guys see that? So when we flip it over the y-axis, guess what changes sign? The x values, okay? So 0, 1, 2, 2, and 4, 3 change all of those x values to a negative. 0, change it to a negative. Is it still 0? Okay, so that one doesn't move. Put a dot right there. 2, 2 is going to change into what? -2, 2. So it's going to be right here. 4, 3 is going to be -4, 3. So it's going to be all the way over here. So we just reflected this graph over the y-axis. Now, one way that you can check that you did everything right is that your line of reflection, your parent function, and your transformed function should all intersect at the same point. Do you see how all three lines meet in the middle? That is a good check, okay? We did it right. Check your previous one, right? As long as all 3 points meet up at the same point, we are golden, okay? Any questions on these two? Okay, we're gonna do one more example. I'm sorry, 2 more examples, and then we'll move on to stretches and shrinks. My favorite. Okay, so next one, we've got our parent function of negative 4x minus 2. We should all be champions at graphing parent functions by now. How am I going to graph this? I need a volunteer. Emma, go for it. Excellent. So we got a dot at negative 2.
And then since the slope is -4/1, we should either down 4 and over to the right 1.
Excellent. And let's do it one more time. So we've got these 3 points. You guys with me? Okay. All we did was we went down 4 units. Oh, did I go down 3? Yeah, I messed up. Should go down 4 and then to the right 1 because our slope was negative 4/1. Okay, so what are my 3 points? Well, this one's 0, -2. What's the next one, guys?
1.
Carl?
1, -6.
1, -6. And the last one? Grayson?
2, -10.
Excellent. 2, -10. Okay. So then go ahead and draw a line through those points. Label it your parent. And then we're going to transform it after that. Okay. Okay. So we've got these 3 points. We've got our parent function. Now we have to graph it with a transformation. So we're making all of f of x negative. Go back. When we make f of x negative, right? In your notes. Very good. So we are going to draw our line of reflection on the x-axis. So draw your red dotted line on the x-axis. Okay? If we are going to flip all of these points over this axis, right? What values are we going to change? The y or the x values? Emma? Y values, okay? We're going to make all of the y values change their sign, okay? So underline -2, -6, and -10, and just change them to positives. So 0, 2 is up here. 1, -6 will become what? Layla, say that a little bit louder. 1, 6. And the last one, 2, -10 will become 210. Okay? So I just changed all of my y values to become positives, okay? Because they were all negative. We're just changing the signs. We draw a line through these points. Now, I'm not drawing perfectly straight lines. You guys should be because you're in Notability. But your graphs should get close to crossing all 3 of them at the same point. Do they get pretty close? Okay. If you didn't, maybe you plotted a coordinate wrong. Okay. This is a reflection over the x-axis. this is a reflection over,
The y-axis.
very good. Reflection over y-axis. Okay, so our dotted line is going to go along the y-axis. Copy over your parent function, which was 0, -2, 1, -6, and 2, -10. One -6 and 2, -10. Okay. Now, in the previous example, we changed all of our y values. We changed all of the signs. What are we going to change in this example? If we're flipping over the y-axis. Carl? The x values, okay? So underline all of your x values of your coordinates, 0, 1, and 2, and change their sign. So 0 is neither positive nor negative, so that one's just going to stay the same. 1, -6 is going to become -1, -6. Yep, and then the last one's going to be -2, -10. Are we starting to see it? A little bit? Okay. So now you draw a line through your blue transformations, and you draw a line through your parent functions, which are in black. Do all three, parent, transformation, and line of reflection, cross at the same point? Yep. And which point was that? 0, -2. Okay, this bad boy right here. Why? Can someone explain why does 0, -2, why does that point not move? What's so special about it? Eli? The x is 0. What else is unique about it? You're right, Eli. What else is unique? Because when x was 0 over here, do you see how it still moved? Eli?
It's the, what's it called? Y-intercept?
It lies on the y-intercept. And in this case, our y-intercept was what? Our line of reflection. Our y-axis was our line of reflection. If a point ever lies on your line of reflection, it's not going to move, okay? That'll be the one point that is the same whenever you reflect it. Do you see how it didn't move at all? Over here, our point was somewhere between 0 and 1, -1. You guys saw that? Okay? So that is the point that did not move. All right. Any questions on reflections? Okay. So before we start talking about what a horizontal and a vertical stretch or shrink looks like, okay, go ahead and go all the way down to this teaching tip, okay? I want to show you guys what a stretch looks like so you guys know how to identify it, okay? We're going to plot these 4 points to draw a little square, okay? So go ahead and plot 2, 2, 2, -2, -2, -2, and -2, 2. Plot all 4 of those points and then label them, okay? Okay. It's one of my favorite parts. All right, what we're going to do is we are going to multiply, right, in a different color. Make sure it's a different color. Right over here on the right, we're going to multiply all x values by 3. multiply all the x values by 3. Okay? And how we do that, we take all the x values, so underline all the 2's and negative 2's that lie in the x position, and multiply them by 3, and then plot the new point, okay? So for this first one, we had 2, 2. You take the 2, you multiply it by 3, we should have 6, 2 as our next point. 6, 2 is all the way out here, okay? So all I did was I took the x value and I multiplied it by 3. What would this point down here change into if we multiplied the x value by 3? Emma? 6, comma? Excellent. It would be 6, negative 2. Okay? What about the ones on the left? What about this one up top left? Negative 2, 2. What would that new point be, Zoe? Excellent. Negative 6, 2. And then the last point down here, bottom left, what would be the new point after we multiplied it by 3? Diana?
6, -2.
Negative 6, -2. Perfect. Okay? Now, draw a new shape connecting those 4 blue dots. Now, if I asked you to describe what happened when you went from the red box to the blue box, how would you describe it to me? Eli? It got wider. How else would you describe it? Yeah?
It's no longer a square.
It's no longer a square. It's what?
A rectangle.
A rectangle. Okay? What I want you guys to visualize is visualize grabbing a hold of both of these red sides and pulling them apart, right? Imagine it's like Play-Doh and you pulled it apart and you stretched it out, okay? This is what we call a horizontal stretch. By a factor of 3. Okay? We multiplied all of our x values by positive 3. So we grabbed the 2 sides of our square and we stretched them out to make a really long rectangle. Okay? We made it flatter. But notice, did the x values change at all? Did we change the graph vertically? No, we just kind of stretched it out, right? This is a horizontal stretch. Nothing happens vertically, okay? Now, our next assignment, change colors, is we are going to multiply all y values by 1/2. Let's multiply all the y values by 1/2. Okay? So let's underline all of our y values. 2, 2, -2, -2. And then multiply them by 1/2 and plot the updated coordinate. Okay? From the original square. Okay? Don't use the blue coordinates. Use the red ones. Okay? Multiply those y values by 1/2 and then tell me the updated coordinates. Okay? You should have gotten 2, 1 because we're dividing this by 2, so we get 1. You should have gotten 2, -1 because you're dividing -2 by 2 to give you 1, or -1. then you should have gotten -2, -1, and -2, +1. So you should have gotten that little green square in the middle. Does everyone see how I got that? It absolutely did shrink, okay? So we're going to write that it shrunk. Did it shrink horizontally or vertically? Vertically. So it's a vertical. And I put shrunk. It should say shrink. So just change that U to an I. By a factor of 1/2. All right, now I do have a little challenge question. So we multiplied each of these, right? We multiplied the x values by 3, and we multiplied the y values by 1/2. Why were the x values, why was that a stretch? And why was it a shrink when we multiplied the y values? Cooper, what do you think?
Would the stretch move along? Would the stretch move along the x-axis?
Yeah.
And with the shrink, you move along the y-axis.
Okay, but why was it a stretch when we multiplied by 3? Why was it a shrink when we multiplied by 1/2? Camilla?
Because when you, like, it's like when you multiply by 1/2, the numbers are shrinking because it's like
Oh.
1/2 is smaller than 3.
Very good. 1/2, that was awesome, okay?
Corruption. Maria Aranguren. Maria Aranguren, please report to student services. Thank you.
So if it's not part of opposite world, it's going to be a vertical, stretch, or a shrink, okay? Now, if A is a big number, like 5, you're going to stretch it out 5 units. If it's a small number, like a third, you're going to shrink it a third, okay? You're going to shrink it by a factor of 1/3, okay? So take a look down at the example. Do you see how if A is really big, you're going to get a graph that looks like the blue line where you're stretching it out? And if A is small, from the parent function, you're going to shrink it down. You're going to make it nice and flat, okay? So those are the two differences vertically. Now, for horizontal, it gets a little tricky, okay? Horizontal stretches and shrinks. Do you see how the A is inside the parentheses? Do you see the difference there? For a vertical stretch, A was outside, right? A was being multiplied by F. For a horizontal, it's going to be multiplied by X, okay? Now look, what did I say this area is called inside the parentheses? Emma? Opposite world, okay? Now in opposite world, everything you think is going to happen is not going to happen. Everything that shouldn't happen happens, okay? So now if A was like 3, right? We would think, okay, we're going to stretch our graph out 3 units horizontally, right? But actually, we're going to shrink it 3 units horizontally, okay? Because we're actually stretching or shrinking by a factor of 1 over A, okay? So the graph of y equals f of x looks like this. If A is really big, okay, we're going to shrink it horizontally. And if A is really large, we're going to stretch it out. I'm sorry, if A is really small, we're going to stretch it out horizontally, okay? This will make a lot more sense once we do an example because I see some faces I don't like, okay? Yeah, sure. So go on to the next page. Let's try some of these transformations, okay? So in the first one, we've got f of x equals x minus 1, okay? So our parent function is f of x equals x minus 1. That means we're going to put a dot at -1 on the y-axis. And what's my slope of this equation? Diana?
1 up, 1 right?
Yep, 1 up, 1 to the right. So our next point would be 1, 0, and then we can do one more and make it 2, 1. So we've got these 3 points, draw a really nice line through all 3 of them, make it a nice parent function, okay? And you guys, since you're a notability, okay, once you complete this parent function, go ahead and copy it right over to the other graph, okay? Because we're going to use that same parent function for the graph on the right. So once you're done copying down the parent function, you label all your points. Go ahead and copy that whole thing over to the right. So we are going to take a look at our transformation, okay? G of x equals f of 1/2 x, okay? Now, let's pretend we're regular people. If we're multiplying something by 1/2, is that going to shrink or stretch our graph? Shrink, right? We normally think shrink, but where is the 1/2 located?
Inside the parentheses.
In opposite world, okay? So, it's in opposite world. So instead of shrinking, we're actually going to do what? Eli? What's that? Stretch it out. Very good. So this is a stretch. When it's inside the parentheses, is it a vertical or a horizontal stretch? Emma? Horizontal. So it's a horizontal stretch. But look at this. By a factor of 2. Why is it by a factor of 2? Sabrina? Ah, very good. Okay. Just flip this fraction and it becomes 2 over 1, right? Okay. So we're actually going to stretch it by a factor of 2. Okay. So go down here. If it's a horizontal stretch, we're going to multiply our x values by 2. So every single x value, multiply it by 2, okay? So the 0 gets multiplied by 2, the 1 gets multiplied by 2, the 2 gets multiplied by 2, okay? 0 times 2 is just 0, so this one doesn't move. 1 times 2 becomes, so 2 comma 0 is my next point. And then 2 times 2 becomes 4. So we've got 2 comma 0, and we've got 4 comma 1. My graph should look something like this. Now, notice, make sense of it visually. Do you see how if we took the black graph and stretched it like Play-Doh, kind of like stretched it along, it would end up more like the red one, okay? We stretched everything horizontally. We made it really, really wide to look like the red one. Okay? Do you guys kind of see that? No? So let's go up. Let's figure out what our transformation is doing, and then let's perform it. Okay? What is going on in this transformation? H of x equals 3 times f of x. Well, first off, where's the number? Is it inside or outside the parentheses? It's outside. So automatically, we know it's going to be a horizontal or a vertical shift. Not a shift, but it's going to be vertical, okay? Anything outside your parentheses will be vertical. Anything inside will be horizontal. So we know it's vertical. Is it a stretch or a shrink? Emma? It's a stretch. Why don't we switch it and say that it's a shrink? What's different about this problem versus this one? Joseph?
The number is not in opposite world.
Correct. The number, which was 3, do you see how it's not in opposite world? The only thing in opposite world is x. So nothing's actually opposite here, okay? So we are stretching it by a factor of what? Excellent. By a factor of 3. Okay, so our graph, if we're stretching it vertically by a factor of 3, we're going to multiply all of our y values by trace, okay? So, underline all your y values, -1, 0, and 1. And multiply them by 3. So 2, 1 becomes 2, comma 3. 1, comma 0 becomes 1, comma 0. Stays the same. And 0, comma negative 1 becomes 0, comma negative 3. I took every single y value and I multiplied it by 3. We draw a line to connect all of these. And that's our updated transformation.